Two identical thermally insulated vessels, each has 1 mole of gas, of the same gas, at temperature T1 and T2. When the valve is opened between the two vessels, what is the increment in entropy? So we have two vessels, each has 1 mole and temperature is T1 and T2, and then we are connected. Then let's say the final temperature becomes T. Now by symmetry, again each of the vessels will have 1 mole each. So we can equate this situation to similar situation where this gas of at T1 turns to T and T2 turns to T. So these end states are exactly same. That's why we can individually do that. So it's possible because their number of moles are same. And now to get the entropy change, because we are only consider about the initial and the final states, so let's consider an isochoric process because the volume of both the vessels is same. So this is our approach. First let's find the temperature T, and then once we have the temperature T, for this isochoric process we can find delta S1, and for this process we can find delta S2. But first we need temperature. So from here to here, because the vessels are thermally insulated, Q is 0, and because it's a free expansion, when you open the valve, W is also 0, which means delta U for the system is also 0, which is delta U1 plus delta U2. So delta U1 for the first gas is Cv into T minus T1, delta U2 is Cv into T minus T2. You simplify that and quite obviously we get the result. The final temperature is T1 plus T2 by 2. Now delta S is equal to delta S1 plus delta S2. So delta S1 from here to here for isochoric process is Cv ln ratio of temperature. So we have seen this a lot of times, but still I write it so you can just imagine that ds is Cv dt by T, because in isochoric process dq is Cv dt. So limits should be from T1 to T, and for the second gas T2 to T. Simplify it, you will get the result in terms of T, put the value of T and you will get your answer. Now demonstrate that delta S is always greater than 0. So Cv is positive and we have this term here, and we know by maths this term is always greater than 0, because if you take it here, this becomes T1 minus T2 whole square. Therefore delta S is always greater than 0. Alright.